Hello everyone. Welcome Professor Marin Junior from sorry pronunciation.
Not great, but looks good.
From University France Com, and she'll be giving a series of lectures on an introduction to PARI GP.
Thank you. So first, I want to thank Emily and Rashi and everyone who made this possible, because it's not an easy thing to come from France to here to give some lessons, and I'm very, very happy to do it. So I will speak all this week about this software, PARI GP. You may know that this is a software made for number theory by number theorists. So if you are doing some number theory, you should use it. The talk of this morning will be a quick introduction to the software. I saw that some of you never used any computational software like Sage or Python or something like that. So I will begin with basis. I will give you kind of talk during maybe less than 1 hour, and you will see after that that I prepared some exercise sheet. So if we finish a bit earlier, you can try to do some exercises and I can just get around and help you. I really want to apologize for my English, which is a bit trashy, but well, I will do my best. And I hope that everyone managed to install the software. If not, we can try to fix the issues at the end of the talk. So first, if you go to the webpage of this series of lecture, you will find a link to this page, which is on the official website of PARI GP, and it's a page dedicated to this lecture series. And on this web page, you will find here is the slides of this morning. Here with code, you can download the text file to copy paste every function that I will present to you, if you want to try to do it in the same time. And here, this is the exercise sheet for this morning talk. And every day I will update. So I try to plan the end of the week, but maybe it will change. So don't pay any attention to the title of next talk. Maybe I will change my mind. So is it working on you?
Is there a binary for Linux?
There is a binary for Linux, but you have to. The easy way to install PARI GP with Linux is to use Git. But it's a bit long, but you may find on the page of the series of lectures some instructions for Linux users. So let's begin. If you run the software, you should have something like that in front of you. So it looks like a terminal for coding, but it's really the interface of the logiciel, of the software. So you may see that people really don't care about aesthetics, but it's really efficient. So here you can try to do some addition, for example, and you can see it's able to compute 1 plus 2. Great thing. So before going inside the software, I want to present you the name of the software. It's named PARI GP. PARI because of Pascal arithmetic. It is C library, which allows fast computation. GP is an easy-to-use interactive shell, which gives access to the PARI function. So all the functions are in this library. You can access with GP. GP with capital G, capital P is the name of the language. And you also have, you may meet GP2C, which is in fact a compiler going from GP to C library. So you don't really need to know that to use it. So first, what you really need to know is how to find information on functions, because you have a very huge amount of functions in that software, and it's really difficult to just have every function in mind. So every link here, you can click on. It doesn't. Okay, with Zoom it doesn't work, but you can click normally on everything to make it open. So this PARI-GP Users Guide is a kind of, I would say, I don't know. It's a very, very huge document with everything inside. You can find every help documentation inside. So this one, you should have it in your computer. But if you want to go faster, you can use ref cards, which are PDF with all the functions and all the arguments that you can put inside. But you have no explanation on it. It's just to have it in mind. So you have ref cards on 5 topics, 5 main topics. So the basics, number field, delicate profile functions, and modular forms. But you can also use directly the software to get some help if you want to know more about a function. For example, if you ask a question mark Ethan, I misspelled it, you have a short help. It says that Ethan is arctangent of x. If you want to know more about the function, you can try double question mark. It will open the complete documentation of the function. So here you have a more complete explanation, and sometimes you have some additional information, for example, about the complexity of the function or about the method used to compute one thing inside. You can also have kind of computation, I don't know, type information of the function. So this is to get help. You can also, if you don't really know what is the name of the function, but you remember that it begins by, I would say, Galois. Let's try. So you begin to write your function name, Galois something, and then with double tab, so I cannot write it, but with double tab, you can have access to all the function name beginning by Galois. It's quite useful when you almost know which function you want to use, but you forget the full name. So this is another tip. If you want to write a function quite quickly, you can use tab for completion. For example, if I want, I don't know, Galois init, I would take Galois in, and with tab it completes the name of the function. It avoids every typos. So that's for the beginning. So the help access is really central in using the software. And you can also find this user guide and the ref card inside the directory where you have all the files, PARI-GP files. There is some directory documentation. I don't really remember the full name, but it's about documentation. You can also access to the ref card directly from the software. If you try double question mark ref card, you will have the list of all the ref cards. If you want to open one, you can put double question mark and then the name of the ref card. This one is for number 2. If you want to access to one of the tutorials that are available, you can try double question mark tutorial. And if you put 3 question marks and then a word, it will give you a list of functions, and it will choose a function by searching this word inside the documentation of the function. I mean, if you open the documentation of MathDev, you will see the word determinant inside. And after that, it can give you some advice. I mean, you can have a look at stuff. If you're on Linux, here, maybe you don't have the question mark, but you have some numbers. It's referred to a list of topics. So question marks are your friend. Well, now you know how to use some help documentation. You can begin to use the software. So you have some basic commands that are common to every math software. The assignment operator, which is equal. If I put a equal 1, it will give me 1. If I ask for a after, it will give 1 again. And if I want to type something, but I want to write something. I want the software to execute my command, but I don't want it to be printed on the screen. Just add a semicolon at the end. If you use the enter sign, you will execute your code. If you need a way to write multiple lines, just add a backslash. You can use either a backslash somewhere, or you can just run the line by braces, which is in here. And if I need to define some user function, if I want to define the function f of x, I will declare all the local variables. Sometimes we just forget to do that, and it's a total mess. So you declare your variable, then you explain what you want to do, and you close your curly bracket. It's something looking like what you can do in C or Python, but be careful to the syntax. It is not exactly the same. You can put as many entries as you want, and we will see later how to get something back. But this is with return. And if you want to put some comments in your code, it's useful to remember after what you want to do. You can use two different ways. Either you put a double backslash and then everything will be commented till the end of the line, or you can surround your text with slash star and then star slash. Yeah.
It's dynamically typed. We don't have to see what type.
You don't have to say what type of variable. It's quite easy to use because it will understand what you want to do. Most of them.
But if you don't say mile, then what happens?
If I don't say mile, it can interfere to other variables. For example, here I already have an A. Here I use an A. If I don't say mile, it can use this one to do that.
Okay.
And I don't want it. So you can do what you want to do. I mean, you can add two numbers. You can have a factorial sign. This is a division sign. You can divide. It will give you exact results. This is for you. I don't know the English for that. This is the question of wisdom. This is a reminder. You can use some complex number, and for the exponent, this is the hash sign. But I think you can also use star star. It may work. You can use a negative exponent, of course, and it will give you some, I would say, reasonable results. I mean, here is a polynomial. It will give you back a quotient of two polynomial at the end. You can also do modular computation. You can use mod to go into z over 5z. And in that case, all the computation is made in that range. So for example, here it's quite faster to first apply mode, then do the power 3, then to do the converse, because it will use congruency at each step. And you can also go into Gaussian by polynomial to define, for example, some fields. So tell me if you want me to go slowly. No. The last one. Here you want to write x mod x squared plus x plus 1. What you think is that I'm in Q of x, y. I mean, I have two variables, and I want to question by, no, I'm sorry. This is not this one. Just forget that. So here you are in Q of x, and you just want to question by that to define a field. And this one is another example, and I just switch both. I'm sorry. We play both.
Even one from other is forgetting.
I'm sorry?
Yeah, even one the sun didn't get it.
I did not get that. What is the problem? There is no problem.
He's asking instead of Q or over rationals, if you want over integers.
Oh,
In this case, we
it
want
will compute in Q, but at the end, if you have something with integers coefficient, it will give you in Z of x, in fact. It will choose the domain according to what you give it. But it will prioritize on fields because usually everything is easier in fields. So you also have your favorite constants. I mean, you have pi, you have log 2. You can choose your precision. Here I can just have more precision if I would backslash key 100. You can specify the precision, sorry, in digits or in bytes, as you want. You can refer to the previous results by putting this % sign. You can also refer to another one specifying the number. For example, if I put exponential of %12, it refers to this one. If I want exponential of log 2, I will put it here, %9 instead of 2. Okay, so it's the history is kept in mind. You can always refer to previous results. Just be careful to this one. If you do not specify the number, sometimes you just reuse the function and you may not remember that each time it used the result just before. And what I was trying to badly explain earlier is the notion of polymorphism. It will choose the domain where your input makes sense and where it can perform the computation. If you try with factor, I think this is the best example. If you want to factorize some number, I mean, it's integer, you have this. Here, 91 is 7 to the 1 times 13 to the 1. So it's made in Z. If you want to factor a complex number, it will give you this one. So here you are in V plus D of I. If you want to factor a polynomial with integer coefficient, it will give you some factors with integer coefficient. The same with complex. If you give it some mod element, it will give you back some mod element. So it's easy to use because you don't have to specify the domain, but sometimes you forget it, and if you are working with mod elements, you can forget to specify that this is mod, and after that having a result which is not the one you expected. But it's really made to be easy. You can also use vectors and matrices. This is not, I mean, if you use Python or Sage, you may have the habit to use this. In PARI, I will not use, it's not made for, I mean, use vector or matrices to store your result. You can use this, but for very specific things, for example, I don't know, I have no example. We never use this in PARI. If you want to concatenate two things, you will concatenate two vectors. So use vector. It's defined like that with commas for vector and just brackets around. If you want to transpose, you just put a tilde after. You have also a function which is mat transpose, made for transpose, but tilde is quite fast. If you want to define a matrix, you will separate the element of one line with comma and the different lines with semicolons. So here it's a matrix with 3 columns and 2 lines. Okay, and then you can multiply with the usual side sign. You can multiply 2 vectors, you can multiply matrices, it's the same. And you also have some easy way to define vectors. I mean, this defines the vector of all the integers from 1 to 10, 1 and 10 included, for example. And if you need to access to something specific inside the vector or inside the matrix, it's I would say like you think maybe. If V is a vector, V of 2 is the second element of the vector, we begin counting at 1. Okay, if you are used to Python, it's 0, so be careful to the confusion here, it's 1. If I wanna extract parts of the vector, I will give the software the first element and the last element I want to extract. So here is the 2 first elements of W. Okay. For matrix, it's the same number of the line, number of the column. If you want to extract 1 element, if you want 1 line to specify the number of the line, then nothing. If you want 1 column, it's the same, nothing, comma, the number of the column. And if you want to extract like the submatrix, the same. Which line you want to begin, which line you want to end, which column you want to begin. So it's really easy to build some block matrices, and it's also very easy to extract some blocks. So even if you just want to store some results, you can define matrices with anything inside. I mean, it doesn't have to be, well, it doesn't have to be numbers. You can store some polynomials or even maybe some groups. Oh, it doesn't switch. Maybe I can get. This screen seems to be frozen. Oh, wait a minute, I started. This is the next thing. So you can also use compilation syntax. I'm not sure about this in English. In French, c'est sans compréhension. Here you say that you will have all the squares of number between 1 and 10. Okay, so this is clear. You can put some conditions. Here I want all the squares of numbers between 1 and 10 that are primes.
Is it a dash after this tree in front?
Uh,
Yeah.
so bracket,
Yes.
here it's I don't know the name of the sign, but well. Interior, this is a minus, this is a bracket.
The minus.
Yeah, it's to like draw kind of a row, you know. So yes, if you add a condition with the Boolean stuff, you will have only the number that is not. You can also use the equal sign for multiple applications. I mean, here, when I write that, I say A is equal to 1 and B is equal to 2. And after, each time I type A, it will understand 1 and B. And you can use print function if you just want to see something. For example, when you have a quite long function and you just want to see if all the parts goes well, you can just ask for printing. And you can put some strings if you use this symbol. I don't know the English name of this. What symbol? What symbol? So if you want to write your own function, at some point you will need some programming stuff. And mostly the control expression. So this is the same if for while that you already know. But the syntax is into the software. So it's quite easy. You name it. I won't make it. You have some parentheses around. Here you put your condition, which has to be a Boolean stuff. Then what you want to do if it's true. And if I just put my parentheses here, I have nothing for else. And if you put a comma on something, it will mean try that. If it will do that, else do that. Okay, so the second comma is else. You never write it, but it means else. Same for the while. While this condition is true, do that. You have to put your variable. I mean, for example, for x equals 1 to 10, 1 and 10 are included. Do that. This should be an expression in this variable if you only use it. If you just want to, I don't know, if you just want to repeat something 10 times, you can also do another instruction. Okay. So with this form, you have several functions that are quite useful to avoid you to make some loops inside loops. For example, first step, which allows you to go, for example, from 1 to 10, but 2 by 2. So in that case, you specify the beginning, the end, and the step. So if you just want to have the even numbers, you will put a step 2. And then the expression. You can also bring only 2 prime numbers, the start end, and for prime will go from a prime number to the next one. And thirdly, allows you to compute some sums where the sum is over all divisor of a specified number. So here you put n, which is your number, and then your variable, here it will be b, and the expression. And you will compute that. Could be useful to know if it exists. And you can also use forvet, which when you read the documentation, it's a bit tricky to understand, but it's easy. Look, I just wrote everything for you. You have to give it a vector with two vectors inside. The first one going from A to B, the second one going from C to D, and then something to B. So this expression, I will call it F after. It will give you back F of ij for every I, every j. This is what I wrote. So it can allow you to do some parallel computation, and it's quite fast comparing to loops and loops and loops. I'm sorry. I wrote some things that you cannot read because it's too long. There are some other functions in this kind of thing. I will just adjust my page so that you can read it. But I think it's the first one you may need if you want to write your own function. And at some point, you can have this error message, PARI stack overflow. That means that the default memory used by the software is not enough to make your computation. So you can locally increase it, or you can go inside your file to specify quite huge PARI size max to avoid this break. But it's not mandatory. Maybe you don't need it. It's just if you want to compute something quite huge. I think you will need it when we will do some number field computation, because number fields can be really, really, really huge, and we have to compute a lot of things. But you can just say yes each time it will break. Say yes, I want to continue. Yes, I want to continue. So this is the end of what I wanted to tell you this morning, because I want you to practice. So you can go on the exercise sheets and you will find a lot of things according to your level to try, and I can help you. And for the next lecture, at the end of the week, here is what I will explain. So tomorrow, I think we will focus on polynomials and their extensions, and also finite fields, because we need to know how to compute fields with polynomials. Wednesday, I think we will focus on number fields and classical theory. The Thursday, elliptic curves, because we have some way to compute ranks of elliptic curves and rational points, and some it could be useful for those among you that study elliptic curves. And the last one will be on L functions and model for Magnet. But if you have a specific need, I mean, if you have your own project and you want me to present something else, just ask. Because I prepare the lecture from a day to the next. So I can totally adapt to you. And if you have some personal project that you want to do this week, or maybe next week, I will be here until the end of the month. And I have an office, this is 206. So if you want me to help you to do something, just do not hesitate. Come to me and we'll try to work together. I'm here for that, and to make you use the software as you do. Okay? Well, thank you for listening, and now go to the exercise sheet. Ask your question. And anytime you have a question, just raise your hand and ask.
I have a question which is not related to that. So
Okay.
each has PARI as a
Yeah.
part of it.
Yeah, but you don't have the full PARI. Yeah, there is a lot of things that you cannot do to page.
Yeah, but I was not able to do anything. I mean, it was like giving some error.
Oh, the news PARI.
Yeah.
Yeah, I'm not using Sage, so I cannot help.
Okay. And the other question is, so we've been using the interactive mode, right? So if there also can, do these things compile if I write some code in deeply and then I can compile?
Yeah, you will find. Oh, yeah, I did not speak about how to write something in a text file and then import it into the software, but of course it's possible. And you have all the explanation in the exercise sheet. There is a section reading file devoted to that. Yeah, of course you can. If you're ready. But the exercise sheet begins with something really basic. So if you never used any software format, maybe you can start with that. If you are quite used to several languages, maybe you can start with programming to develop the syntax. If you have something like break, you just have to type break and it breaks. Or control C.